Welcome back to the deep dive. Today we are wading into waters that, let's be honest, usually require a lifeguard on duty. We're talking about Haskell.
Oh, yeah.
That one.
Haskell. It definitely has a reputation.
A big one.
You say Haskell at a developer meetup, and half the room thinks of academic papers and the other half just sees these like incomprehensible math symbols.
Exactly. It's the language that makes people feel like they need a PhD just to write a hello world program. It's
Yeah.
often seen as this daunting ivory tower beast.
Impossible to tame for practical work.
Right.
Which is why today's source is so refreshing.
Yeah.
We are looking at a textbook written by some computer science professor.
Uh-huh.
We're analyzing a blog post from qianmeng.org, published today, Tuesday, February 3, 2026.
And the author, Eng, explicitly describes himself as an old software plumber. I love that. It feels so grounded.
It really does. It suggests a practical approach, right? He's not talking about category theory for the sake of it.
No, he's connecting pipes.
He's making things work. And he's chronicling his journey of learning Haskell incrementally, basically just taking notes in public.
And we are looking at specifically Notes on Haskell Programming, Part 48. 48 parts. That is some serious dedication to learning.
It gives us a great context. We're jumping into the 48th step of a long journey. And the project he's building is a console application called X2 eBook.
Which sounds handy, converting things to ebooks. But we aren't building the whole app today. The mission for this deep dive is actually, well, it's very small, very specific.
The task is simply adding a command line interface argument. He just wants the application to accept an input text file path from the user.
That's it. I mean, in Python or JavaScript, you might just grab an index from an array of arguments.
sys.argsv1 or something.
sys.arsv1, and you move on with your life. Takes 10 seconds.
In imperative languages, yeah, it's often a quick and dirty array access. But in Haskell, as we're about to see, even a simple task like hold this file path forces you to make some pretty fascinating architectural decisions right away.
It sounds like over-engineering, if I'm being honest. Why does reading a file name require architecture?
Because Haskell demands that you define the shape of your data before you can do anything with it.
So you can't just pass strings around loosely.
Exactly. You can't just hope for the best.
Okay, so let's unpack this. The source gives us a specific code snippet. It's just 4 lines that supposedly solves this whole problem. I want to read it out so we can all visualize it, and then we're going to tear it apart line by line.
Let's do it.
Okay, here's the code. It starts with the keyword data. It says that data args, input file path, deriving, show, EQ.
And right there is a massive amount of computer science concepts compressed into that single sentence.
Let's start with that first word then, data. I'm guessing this is just declaring a variable.
Nope, and that's the first trap. Data is the keyword Haskell uses to declare a custom data type. Formally, this is known as an algebraic data type, or ADT.
ADT. Okay, that sounds exactly like the kind of academic jargon we were just talking about. Why do we need to call it algebraic?
It sounds intimidating, but Eng, our guide, he breaks it down with some really helpful comparisons. So if you're coming from Python, you can think of an ADT as being pretty similar to a data class.
Okay, that helps. A data class is just a tidy way to bundle data together.
Right, or if you know Elixir, he compares it to a struct. At the end of the day, it's a way to structure your data. You are telling the program, hey, I have a new type of thing called args, and here's exactly what it looks like.
Okay, but looking at the syntax, I have to ask about something that always confuses me when I see Haskell code.
Go for it.
It says data args equals args. Why is the word args there twice? Is that a stutter? A typo?
Right. That is one of the most common stumbling blocks for beginners.
Yeah.
It is not a typo, but it is definitely confusing.
So explain it to me.
Okay, so the args on the left side of the equal sign is the type constructor. That's the name of the
The
blueprint.
blueprint. Okay.
So when you write a function that takes this data as an argument, you use that name.
Okay, so left side is the name of the type. What about the one on the right?
The args on the right side is the data constructor. It's the actual function or tag you use to create a value of that type.
Why do they need to be separate? Why can't the type just be the constructor?
Because sometimes a single type can have multiple ways to be constructed. Think of it like this, a type called Boolean.
Okay.
The type is Boolean, but the constructors are true and false.
Oh, I see. So it would be like beta Boolean equals true false.
Exactly. Or think of a generic shape type. You might have data shape, circle float, rectangle float. The type is shape, but circle and rectangle are the constructors.
Got it. Okay. But in our case, for the argument parser, there's only one way to be an argument list.
Correct. We're dealing with what's called a product type. We're just packaging one thing together. So by convention, since there's only one version of it, we give the constructor the same name as the type. Data args.
So it's a convention that saves thinking of a new name, but it definitely looks weird if you don't know the rules.
It absolutely does. It looks recursive or, like, redundant, but they live in different namespaces in the compiler.
All right, moving on. Inside that definition, we've got curly braces, input file path. This looks a bit more familiar, kind of like a JSON object or a C struct.
That is what Haskell calls record syntax.
Record syntax. Is that the only way to do it?
No, you could have just written data args file path, and that would just be a positional argument, a slot holding a string.
But Ang chose to use the curly braces, so why?
Clarity. By using record syntax, he is explicitly naming the field input file. This does two things. First, it documents the code. You know exactly what that string is supposed to be.
And second,
it automatically generates a getter function for you. In Haskell, by writing that line, you effectively get a function called input file that you can call on your args object to extract the path.
Oh, that's convenient, so you don't have to manually write a function to unpack it later on.
Exactly. Ang actually quotes the source, saying, Haskell syntax can feel cryptic at first, and it often takes time to internalize. Using record syntax is one of those small steps he mentions to make the code less abstract and more readable.
But the real magic, and I think the core of why we're even talking about this snippet, isn't the data keyword or the curly braces. It's what comes at the very, very end.
Line 17.
Line 17, deriving.
Show EQ.
This is where we leave defining data, and we enter the realm of metaprogramming or, code generation.
Okay, deriving. In English, that means coming from something else. In, object-oriented languages, it usually means inheritance. A dog class derives from an animal class. Is that what's happening here?
No, and this is a really crucial point. This is not inheritance. Show and EQ are not parent classes.
So then what are they?
They're type classes. The best way to think of a type class is as an interface or a contract.
A contract.
Yes.
Okay.
The EQ contract simply says, any type that signs this contract must have a way to check if two values are equal.
And show.
The show contract says, any type that signs this contract must have a way to convert itself into a string for display. Okay. In Python or Java or Ruby, equality and string representation are usually just built into the absolute base object. Everything can be printed. Everything can be compared.
Right. If you create a class in Python, it inherits from object. You can immediately print it. It might look ugly.
Yeah, you get that memory address thing.
The main.args object at 0x7 FA stuff. Wow. But it doesn't crash.
It works, technically, but Haskell is different.
Haskell is extremely strict. It says, I don't know anything about your new args type. I don't know how to print it, and I certainly don't know how to compare it. If you try to print it without that deriving clause, the compiler will just stop you.
So you have to explicitly tell the compiler, hey, I want these features.
Yes, and that's what deriving does. Ang calls it stock deriving. It instructs the Haskell compiler to look at your data structure and just write the code for those contracts automatically.
Wait. So the programmer types one word and the compiler generates the actual logic.
That is exactly what's happening. When you add deriving, show, EQ, you are telling the compiler, please write the boilerplate code to check for equality, and please write the boilerplate code to turn this into a string.
That sounds great, but I want to play devil's advocate here. Is it really that hard to write it yourself? I mean, why do we need a special keyword for it? Maybe I want to write my own equality check.
And you can write your own. But Ang's post actually shows us what that looks like. He calls it doing it the hard way. And honestly, it's painful.
Let's see it. To manually make two args objects comparable, what do you have to type?
You have to define what's called an instance. It's like this. Instance EQ args, where args path 1 or equals path 2. So args path 1 equals path 2.
Whoa, that is dense.
You have to manually pattern match. You have to say, take the first object, unwrap it to get path 1. Take the second object, unwrap it to get path 2. Now compare those two strings.
That seems fine. I mean, it's one line of logic.
It's one line for one field. But imagine your args object grows. Imagine XS2P book gets more complex. Now you have an input file, an output file, a flag for verbose mode, and a flag for overwrite.
Okay, so now I have 4 fields.
Now your manual equality check looks like, unwrap everything. Check if input matches input ND, output matches output, and verbose matches verbose, and the overwrite matches overwrite.
And if I add a 5th field later?
And this is the danger zone. If you add a 5th field to your data type, but you forget to update your manual equality instance.
The compiler won't save me.
The compiler won't save you. The code will compile. But your equality check will be wrong. It will say two things are equal, even if that fifth field is different. You have just introduced a silent bug.
That is terrifying.
It is. But if you use deriving,
The compiler just updates the logic for me.
instantly, every time you compile, it looks at the current structure of the data and generates the correct exhaustive equality check. It's not just saving you typing, it's a guarantee of correctness.
So deriving turns equality into a structural property rather than manual code that can just rot over time.
Exactly. It removes the human error from the plumbing.
I see why the old software plumber likes this. It's a leak-proof pipe.
It really is.
Yeah.
And the same thing goes for show. Writing a manual string converter is just tedious string concatenation. Deriving show just gives you a sensible default that looks like the code itself.
So we've got this contrast. Haskell uses deriving to generate these instances. Python uses magic methods like EQ and str.
Right. And Ang spends a little time comparing those two mechanisms.
It seems like the industry is actually converging on this idea, though. You mentioned Python earlier. Doesn't modern Python have something like this?
It does, and that's a great observation. Python introduced the @data class decorator a few years ago.
And what does that do?
It does almost exactly what deriving does. If you put @data class above your class definition, Python automatically writes the init, the rep, which is like show, and the EQ.
So Python basically looked at Haskell and said, hey, that's a good idea, let's steal it.
Pretty much. The industry as a whole is realizing that writing boilerplate, getters, setters, equality checks is just a waste of human brain power. We should be defining the shape of the data and letting the machine handle the mechanics.
However, and here's the friction point, Ang admits that despite all this elegance, Haskell still feels cryptic.
It does.
Data args, it's not deriving. It reads like a formula. Python's @data class still looks like a class. It feels more approachable.
And that is the trade-off. Haskell optimizes for expressiveness and correctness, but it definitely sacrifices familiarity. Ang mentions that it takes time to internalize this syntax. When you first see it, it just looks like noise.
It's a steep learning curve. You have to learn the secret handshake to know that deriving is writing all this code for you.
But Ang's approach, the small incremental steps, is the way you beat that curve. He isn't trying to understand the underlying mathematics of type classes yet. He's just saying, I need to print this. How do I do it? Oh, deriving show.
She's using the tool before he fully understands the theory behind it.
Which is how most of us learn to cook. Right? You follow the recipe. You don't need to understand the chemical reaction of baking soda to make a cake.
You just know baking soda makes it rise.
Exactly.
So deriving is the baking soda of Haskell.
I like that analogy. It works.
But I have a question about the limits of this magic baking soda. Can you just derive EQ for anything?
Ah, great question. No, you cannot.
Okay, so where does it break?
It relies on recursion. So deriving EQ only works if every piece of data inside your structure also supports equality.
Okay, so our args contains a file path, which is just a string. Strings have equality, so we're good.
Correct. But imagine if your args structure contains something else, say a function, like a callback function on error.
Can you compare two functions?
Generally, no. In computer science, checking if two functions are functionally equivalent is what's called undecidable. So if you put a function inside your data type and then wrote deriving EQ,
The compiler screams at you.
the compiler screams. It says, I don't know how to compare functions, so I can't build the equality check for this parent structure.
So the magic isn't actually magic, it's just very distinct logic building on top of other logic.
Exactly. It's deterministic. If the parts are sound, the whole is sound. If any of the parts are ambiguous, the system halts.
That actually makes me trust it more. It's not guessing.
It's the plumber mindset again, right? If the pipes don't fit, don't force them.
So let's zoom out a bit. We've spent, what, roughly 10 minutes analyzing 4 lines of code?
The density of Haskell is real.
It is. But what does this mean for the listener who isn't planning to switch to Haskell tomorrow? Why should they care about ADTs and record syntax and all this?
I think the takeaway is about data intent. In languages like JavaScript or maybe older Python, we often practice what I sometimes call hope-driven development.
I hope this dictionary has the key file name inside it.
Exactly. We pass around generic objects or dicts and just hope the documentation is right. Haskell forces you to formalize that intent up front. By defining data args, you are creating a universe where only valid arguments can exist.
It pushes the design phase right to the very beginning.
Right. You aren't writing code to do things. You're writing code to describe what things are. And if you get the types right, like this ADT, the implementation often writes itself, or in the case of deriving, literally writes itself.
It sounds like X2 ebook is starting on a very solid foundation. If this is the level of care going into just reading the file name, the rest of the app should be bulletproof.
I'm really curious to see where Ang takes it. The next challenge is going to be doing something with that file. That involves input-output.
And in Haskell, doesn't that involve monads?
It does. The I/O monad. That is usually where the old software plumber meets the ivory tower professor.
Well, we will have to see how Aang handles that collision when he gets there.
It should be interesting.
Before we wrap up, I want to leave the listener with a final thought on this idea of cryptic code. We critiqued Haskell for looking like math homework.
And it really does look like math homework sometimes.
But is a 4-line snippet that hides all the boring logic actually more readable than the explicit 20-line version that shows every single detail?
That is the eternal debate. Is readability about easy to recognize, or is it about high signal-to-noise ratio?
Haskell seems to argue that deriving is the ultimate readability because it hides the mechanism and it shows the intent. I want equality. Simple.
Whereas the manual way shows you all the gears turning.
And I think as systems get more complex, I'd rather see the intent than the gears.
I'm inclined to agree. Once you trust the gears, you stop looking at them.
Exactly. A huge thanks to Aang at kianmeng.org for sharing his notes. We'll be keeping an eye on XS2 ebook.
Absolutely.
Thanks for diving deep with us today. Keep your type strict and your pipes connected. We'll catch you on the next one.
Bye, everyone.